Okay, we are doing solving equations. A brief review. What are we trying to find when we are solving equations? What are we actually trying to find?
The equation.
The answer.
The answer, which stands for the x or the variable, okay? But what is true about that? So we're looking for, when we're solving, we're finding the value of the variable. What does that value do to the equation? When I put it in, how do I check it? What does it do?
It makes instead of a algebraic equation, it makes it an actual equation.
And what is true about that equation that you write?
You can make an equal sign.
Yes, that makes that equation true. So it's the variable that actually makes the equation true. So when I substitute it back in, it should give me an equation that's actually true. So you can check every one of your answers and make sure you got the right answer. Okay, so yesterday we talked about something like this. This is a very basic one. Okay, 2x minus 3 plus 4 equals 4. Okay, it's an equation. Our goal here is to find the value of x, which means we want the equation to be an equivalent statement where it's x equals. Another way of writing that is 1x equals, because that's what we're really trying to find. What is 1x equal? Okay, just a single x.
X.
Okay.
1x equals x.
Yes, 1x is the same as x because we have an implied 1 in front of it. Okay, what are you looking for?
A calculator. I left mine at home.
We don't need a calculator right now.
You
Okay.
can use mine.
Okay, so this is good. I think I should take yours for once in a while. So the first thing we do is the opposite order of operations. We want to, instead of doing any multiplying, we want to do the adding or subtracting. We want to get rid of a negative 3. So I have a negative 3. How do I get rid of a negative 3? Yes. Add 3. I add 3 because what that is going to do is that's going to make this 2x plus 0. And I add a 3 here. Remember, I have to do the same thing. To keep them equivalent, I have to do the same thing on both sides. So on the other side of the equation, I add 3 to 4 and I get 7. Well, this is basically, we don't have to write this because 2x plus 0 is just really 2x, so I don't have to write that. It's an implied, I don't make you write that. Some people like, and I'm just showing you what some people like to do. Some people like to go like this to say, okay, that cancels each other. That's a nice way of doing that, to show yourself that that makes 0 or it cancels. I don't care how you write. If you just write plus 3 and plus 3 on both sides and then show the result, that's fine. Okay, so that's what I'm looking for. So then I want to get x all by itself. I want to get this to be a 1. So how would I make the 2 into a 1? What would I do, Matt?
You divide 2 on both sides.
Yes, we divide the 2 here because 2 divided by 2 is 1. That's our goal, 1x. Okay, but we also have to divide this side by 2. And we show division usually as the fraction bar now. We're going to get used to writing a fraction bar for division. So this one, you can change it into an improper or mixed number, but you don't need to. So this would just be our answer, 7/2, because 2 does not go evenly into 7. I can't reduce it, so this would be our answer. If you want to, it could be 3.5. That's the mixed number. Or if you want to, in this case, the decimal terminates. So you can write it as a decimal because it terminates, it stops. This is the same as 3.5, but we only write the decimal if it stops. 0.5 is a decimal that stops. It doesn't have any decimal numbers after that are significant. They're all zeros. Okay, so it doesn't have any after that. So we could write this answer in any of these forms. Okay, I don't care how you use it. Now, we are going to check our answer. This is always wise. You should always check, because if you don't get a true equation with that number, then you know you've done something incorrect, wrong. So there's no problems that you should get wrong, because you're going to go check them every time. Okay, so let's check. What we do is we put this number in for x, so it's going to be 2 times, and if you want to go 3.5, that's fine, because that's an easy way, plus, minus 3. I wrote the wrong thing. I was looking at that, trying to figure out what is that, equals 4. Okay, 2 times 3.5. How much is that?
7.
It's 7. Because 3 doubled is 6. 0.5 doubled is 1, so that's 7. So 7 minus 3 equals 4. I can look at that. I don't have to get down where it says 4 equals 4. I can say check, because I know that's a true statement. Okay? You have just checked your answer, and it made the equation true. Okay? So we know it's the correct answer. So again, you can check every one of these problems. So that's kind of a review of what we did yesterday. We talked about equivalent expressions. Well, that was getting it down to here where it's a 1x. We try to get it down to the equivalent equation that has a 1x. Okay? So today we're adding just something in it. And these are things we've done before. We're adding when we have a distributive property. Okay? So if we have a problem that has the distributive property in it, then we just need to do the distributive property either first, and I'm going to show you 2 different ways to do it. So these are going to include distributive property. So say I have 3 times x minus 5 equals 21. Okay? Again, I'm making these up, so probably they'll come out as fractions. I'll just be honest. Okay. There's actually 2 ways to do this problem. Okay. First of all, can somebody tell me what's this? So, order of operations says we would do inside the parentheses first, correct? Then we do multiplication. So we're going to go the opposite way. We're going to do the multiplication first. How would I get rid of that 3? Would I subtract it or would I divide it?
You would times 3 times 5, 3 times x.
You could. Now, that's not the one way I'm doing it. Yes, you can do that. We're going to look at that in a second. Hold that thought. Okay. How else? This is 3 times this. I could divide it by what?
You can divide it by whatever the answer is inside the parentheses.
No. What could I divide that by?
Divided by 3.
If I divide this by 3, what does that become right here?
1.
It becomes a 1. Does everybody agree?
Mhm.
So I could divide this by 3, and I also do it on the other side. Because that's easy division there, I would do it this way. Because 21 divided by 3 is easy division. If it didn't divide it evenly, I might do it the other way that we're going to talk about in a minute. Okay? So this does become a 1. You see my 1? I cancel it out, and that makes a 1. Okay? Oh, come on, that was kind of funny. See my 1? Here, I'll make it more obvious.
No, I see it.
I'll make it very more obvious. There.
Yeah.
See, that's a 1. Okay.
Yeah.
Okay, so that cancels out, and we are left with x minus 5, which now we really don't need parentheses, but we can have them. Okay. equals, well, what is 21
7.
divided by 3? It's 7. So now I actually have this. So how would I get x all by itself? I'm actually doing the division first here. Because I have a set of parentheses, I can do the division first. Okay? So how would I get this? What would I do to solve this equation? Matt?
Add 5.
I'd add 5. I want to get rid of a negative 5, so I'm going to add 5. Add 5. This cancels, so we get x equals 12. There is my answer. Now I'm going to check it because I want to make sure I did all my math right. Okay. My original equation was 3x, which is 12, minus 5 equals 21. Well, this is 3 times 12 minus 5, which is 7, equals 21. Oh, 3 times 7 is 21. I know I've got the correct answer because I checked it to make sure I did. Okay. And so you can check all your equations, all your answers. Now, the true answer to this question is x equals 12. Okay. We don't show, this is not the answer to the problem. This is checking it. Okay. The actual answer is we are solving it. We are trying to get x equal to some number that makes the equation true. We're making sure it makes the equation true. That's what we're looking at up here. Okay. So, I don't have the algebra book up here. Let's see what kind of problems they give us. Because they may go a little bit deeper on this. I just need to make sure what they're going into is, excuse me, 3, 5. Okay, so I'll do a couple like this. Here's one that we're going to do. This is a little bit tougher.
We got this.
Tough.
Okay, so we've got 2 times 3x plus 4 minus 9x minus 7 equals 6. Does that not look like a mess?
Nope.
No?
Not at all.
That's good,
No.
okay. Now, here, we have 2 different sets of parentheses. This 2 is only being multiplied by this set, okay? This negative right here is only going to this set of parentheses. But since the 2 is going to just part of the equation, I can't divide by 2 here. Okay, because there's not just one number in front that we're multiplying by. We're only multiplying this parenthesis by 2. So I can't go over and divide this by 2 because you'd also have to divide this by 2. You have to have just one multiplication with one set of parentheses for that to work. Okay. So, Med,
Yeah.
what am I going to do on this first set of parentheses with the 2 in front?
You're gonna. Oh, I guess we could divide it if we're.
No, we can't divide. I just said that because there's no 2 in front of this one.
Oh, okay. Then we would 2 times 4 and 2 times 3x.
Okay, so we would use our distributive property to multiply the 2 through. Okay, so we're going to multiply the 2 by the 3x and the 2 by the 4. Okay, Mason, what do I get if I multiply 2 times 3x?
Wow, I don't know that. It's probably 6.
Okay, 6 what?
6x.
Okay, 6x. Matthew, what do I get if I multiply 2 by 4? 2 times 4.
Yeah, 2 times 4 is 8.
Okay, so I'm going to say plus 8. Okay, I just did that distributive property. Okay, now we're coming to this. We have a negative sign in front of a parenthesis. What does that mean I need to do with my negative sign? Ava, what do I have to do with that?
Well, you make positive 9x negative 7 positives.
That's correct. We're distributing basically the negative or the opposite. That's another way of saying this. I'm distributing because this is a negative sign. It means either the opposite or make them negative, okay? So the opposite of 9x is negative 9x. The opposite of 7 is positive, or the opposite of negative 7 is positive 7, and that equals 6, okay? So what we did was we distributed through both sets of parentheses. Now at this time, what do you think I'm going to do to finish this problem?
Equalize the terms. Equalize the terms.
What does that mean? Equalize the terms.
Well,
What do you mean by that?
you just put the terms together.
Oh, put like terms together.
Yeah.
That's equal. Okay, that's fair. That's what you meant by equalize.
Yeah.
Equal them, okay? Put them together. We're gonna combine them. So give me two terms that are alike. Brel, what two terms are alike on that?
8 and 7.
8 and 7 are definitely alike. 8 and 7 are alike. What do they make when I add them together? 15. Now, since they are on the same side of the equation, we do not subtract. We're not trying to get rid of them. We are just trying to combine them. So what we're doing here is combining like terms. We are not trying to eliminate anything. We're not trying to get rid of the 7. We're just putting it with the 8. Okay, so we are not, I see people all the time going, negative 7, negative 7. No, that's on the same side of the equation. Remember when we do it to make equivalent expressions, we do it on two opposite sides. We don't do it on the same side.
Could we, I mean, I think I did it wrong, but could we minus 8 and minus 7 on those sides?
Yes,
Okay.
that will be what we end up with because this is a positive 15.
Oh yeah, because eventually we're gonna have.
What are the other two like terms here, Matthew?
6x and negative 9x.
6x and negative 9x. I'm going to underline those by 2. And if I have a positive 6x minus 9x, what does that give me?
Negative 3x.
Negative 3x. So this is negative 3x because I combined them, I didn't subtract or eliminate, equals 6. Now it looks like just like the problems we did yesterday. Okay, it looks just like the problems we did yesterday. We now have some number in front of x plus 15 equals 6. So now I'm trying to eliminate the things around x. Because remember, our goal is to get x equals. That's always our goal. 1x equals. So always keep in mind what's our goal. So we have to get all the numbers away from x. So which number am I going to take away from x first? Mason.
Take away from x.
You know, which one am I going to do first? Am I going to get rid of the negative 3 or the 15?
The negative 3.
Okay, now we always do opposite order of operations. So the thing that was added, not the thing that's multiplied, we do the added or subtracted one first. Okay, how would I get rid of a 15?
What?
How would I get rid of 15 on that side of the equation? I want to make it 0. So how would I do that?
Minusing it.
Minus 15?
Mm-hmm.
So if I minus 15 here, I also have to minus 15 on the other side of the equal sign. A lot of people, when they're first starting this, they might put a line down showing where the equals is, because that shows you that you're doing it on both sides of the equal sign. Okay, that helps to keep it organized. That also helps you to keep from subtracting these, because if I subtract 7 here and here, that's not on both sides of the equal sign. And so that's not what you do. Okay, so what we end up with is that disappears. So I get negative 3x equals 6 minus 15. What does that equal, Med? 6 minus 15.
Negative 9.
Yes, correct. That's negative 9. So now I have negative 3 times x equals negative 9. I want to get a 1 in front of that. So Ava, how would I make it a 1 in front of x?
Divide it by 3.
Positive 3 or negative 3?
Positive.
Hmm.
Negative.
Yeah, because to make it exactly 1, I have, a negative divided by a negative is positive. Okay, so it's very important, if you have a negative in your number, you divide by a negative also. So I'm gonna divide this by a -3. Again, I get my big 1, okay? So I have an x, 1x, okay, which is what I wanted to get, equals -3 divided by excuse me, I said that wrong, -9 divided by -3. Matthew, what is -9 divided by -3?
-6.
No, that's
No, that's-
subtracting
Okay, wait.
or adding. No, that's subtracting. What times 3 gives you 9?
2.
2
No.
times 3?
What the? Why am I getting it? Oh, why am I being weird? What times 3 equals 9?
Yes,
3.
3. Now, the question is, if I'm dividing a negative by a negative, what kind of sign do I get for the answer? It's positive. So in multiplication or division, same signs always give you positive. Different signs give you negative. So if you want to write that down, multiplication or division. This is something you can put in your notes. If or same signs equals positive, different signs equals negative. Since these are the same, they're both negative, then our answer is going to be positive. And then you just do 9 divided by 3, which is 3. So I now have it down to what my goal was. My goal was to get x all by itself, get rid of the 15, get rid of the -3, make the -3 into a 1. We always have to get that to a 1 because we don't want it to be a 0. 0x would not be a good way to write our answer. Okay. Now we can check. We can check what we're doing. So we're going to go back to our original equation. 3 times x, which is 3, plus 4 minus 9 times x, which is 3. So I'm putting these numbers in. Minus 7 equals 6. So we can go through and do the work. Now we follow normal order of operations. So I'm going to do my multiplication inside the parentheses first. So I'm going to get 2 and 9 plus 4, because what I did there was I just multiplied those. Now I'm going to multiply these. 27 minus 7, okay, equals 6. So those two equal that. That's all I did. Okay, I just did the multiplication in both sets of parentheses. Now I'm going to do the addition and subtraction in both sides of both parentheses. So I get 2 times 13, because I added 9 and 4, minus 27 minus 7 is 20, equals 6. Okay, so I did inside the parentheses again, but this time the adding and subtracting. Now I still have a multiplication problem. I have to do the multiplication first before I do the subtraction. So 2 times 13 is 26, minus 20 equals 6. At this point, I know that's true. I don't have to go any farther. Okay, so once it's a basic simple statement like 26 minus 20 equals 6, you are fine to say it's the same. Okay, so you don't have to go farther and write 6 equals 6. Okay, just to let you know, if you ever go to another class, the teacher may require you to write 6 equals 6. I don't, because I think you guys can look at this and say that's a true statement. Okay, but you might have to sometimes. That's something that comes in. So this is basically what you're practicing. We want to get this process very, very much so it's secondhand nature to do solving of equations. That's our goal right now, is to figure out how to solve. Why do we study solving equations? Why? Anybody have any idea? Where would we use this?
We would use it to find x.
In life.
And when would that be in life?
On the map.
I get it.
On a map, we would find x by using
The x marks the
equations.
spot.
Well, I know x marks the spot, but that probably not gonna use equations to
Well,
find
what
it.
about on Minecraft?
No, you wanna use x to find anything.
Okay.
Okay, yes. Think about it. Where would you might use this?
You would count value out. No, maybe.
Maybe
What are
You're
something
trying-
we are given a lot?
numbers.
Test.
Yes. What else are we given that we use? Think about area,
Taxes.
circles.
I don't
Land.
think you'll find x for taxes.
Actually, there are some values that you have to multiply and get, but, okay. If I use area, what is that I have?
Land.
You
It's called what are things like this called?
You're
Volume?
given land.
area equals
Length.
length times width, and then c equals pi diameter. So that's probably
Circle. Pizza.
no. That's a2. That's pi. No, that's pi diameter theorem.
Okay, so what are all those?
All
Equations.
They're
There's some
equations.
Formulas.
They're all formulas. We use a lot of formulas in our life. We probably don't call them formulas, but we do use formulas in our life. And what you're actually finding is whatever you're trying to find, okay? Like if I know my paint covers so many square feet, and I know the height of my rectangle, or we would call that the width, the height of your room, it will help tell you how many feet you can cover on that room. Because you know what the height is, you know how many the gallons of paint will cover, so then you can figure out what length of the room can I paint. So it helps you to figure out some things with that, okay? Especially if you're ordering how many yards of concrete that you need, cubic yards of concrete that you need to make a, let's say a patio, that's a concrete patio. You have to be able to figure out what is the volume of that rectangular area that you have, or if it's a different than a rectangular area, you need to know what the volume is so you don't order too much concrete. Because concrete's expensive and you don't want to pay for more than you have. So depending on what your drawing is, you need to see, or what you plan to fill, and how deep it is, how wide it is, and how long it is, that will tell you how much concrete you have to get. So there's times when we need to know, painting is a good, how many gallons do I need to order to paint my room? Well, we need to know something about the area. Okay, and so those are things that you do use in real life, unless you hire contractors always to do your work. Then they figure it out for you, okay?
But if you're a contractor, so.
If you're a contractor, then you have to know those formulas to know how to get it, okay? So this is where we use a lot of formulas in life to do things. And so that's where we actually come in to use algebra a lot, is we're looking for some of the unknowns. And so whenever we're looking for a single unknown, we are using algebra, okay? So that's, again, going back to why do we study algebra? Because we have formulas in life. Other people figured out how to figure this out. We use the formula they give us to find what we're looking for, okay? And so that's a lot of the uses we have in life for these, okay? So that's basically what we're looking